Hi, I would like to start by saying that this presentation is not mine. Horus Vision kindly sent it to me in an email when I requested it, and very promptly they responded. Great customer service. So today we're going to look at the Horus Vision TReMoR 2 reticle. In the end, this is an instruction manual. It's a tool. All right, let's move into the reticle itself. The first subtension line is at 0.5 mils on each of the axes. This is the first line that is perpendicular to each axis line. The center point on the reticle is a dot, technically not a cross. This dot is 0.05 mils to give a precise point. The empty space from the axis line to the center point is 0.1 mil. We will get into this in greater detail later, but one of the main features of the TReMoR reticle is the adaptable wind hold dots. These dots are larger on the mil incremental lines and smaller on the half mil lines. As a point of reference, each fourth wind dot on the left and right hand side is actually a plus sign. These marks are positioned in 1 mil intervals for standard wind hold referencing, the vertical hash marks. You will find that on both vertical and horizontal stadia, the hash marks are spaced at 0.2, 0.5, and 0.8 increments between each 1 mil larger hash. Below the 10 mil line, the standard Horus mil grid is visible for elevation and wind holds. Each interval is in 0.2 mil. You can keep track of counting mils on both the horizontal and vertical crosshair by noticing the 0.1 incremental growth in the mil lines from 0.5 to 0.9 height. This serves two purposes. They help keep track of mils while counting and can be used for milling measurements. Both stadias have 1/10 mil subtension chevrons to provide an uncluttered means to view measurements down to even 0.02 to 0.04 mils. Here is a close-up, detailed view of what they call chevrons. In this image, you can see how it is capable of measurements in the hundredths of a mil. Next, we will go into actual milling calculations. Milling a target is a reasonably accurate means of estimating distance to a target, given a known target or reference size object at a desired range, or determining an object size when a range is known. Mil formulas are based in tenths and are therefore ideally suited for use with metric units of measure, but can also be used with equalies when you keep the distance and target or object size estimation unit of measure the same. As you can see the formula, if you measure in yards, you can divide the target size by mils, multiply by 1,000 to get distance in yards. Or if measuring distance in yards and target size in inches, you divide the target size by mils measured and multiply by the constant, which in this case is 27.78, to get distance from your target in yards. Here are 3 other variations to mil targets to get distance in meters. And throughout, of course, feel free to pause here or during any of the formulas to make notes for your future reference. Now let's run through a few practice problems in yards. So with a known 12-inch target size, we divide it by what we measure it at, 0.5 mils. So 12 divided by 5 gives us 24. Then we multiply that number, 24, by the constant of 27.78, and we uncover that when a 12-inch target measures 0.5 mils, it's at a distance of 666 yards. We could also consider that same 12-inch target to be a third of a yard, or 0.33 yards. When we divide 0.333 by 0.5, we get 0.666. Multiply that by 1,000 to get that same measurement of 666 yards. On the third equation, we'll mill a known target size of 18 inches, which in this scenario we mill at 0.8 mils. So we divide the target size in inches, which is 18, by 0.8 mils measured, and we get 22.5. Multiply that by the constant 27.78 to get a distance of 625 yards. The final target equation is the same as the previous target, but this time we know that we can also be known as a half of a yard, or 0.5 yards. We divide 0.5 yards by 0.8 mils, which gives us 0.625, and multiply that by 1,000 to get the same result of 625 yards. This is another set of ways to mill distances using a known target size to get a distance in meters. Feel free to pause and run through these on your own. Next, we look at a comparison of the H59 to the TReMoR 2 reticles by Horus Vision. Both of these industry-leading reticles can be found in numerous top-tier scope manufacturers, Bushnell, Leupold, Schmidt & Bender, just to name a few. Where the H59 has wind holds placed in 0.2 mil intervals, the TReMoR 2 has the wind formula represented by dots, along with the hash marks we mentioned at 1 mil intervals. We will see how the wind dots can be calculated to your specific ballistics from any caliber, 5.56, 308, 300 Win Mag, 338, and beyond with ease, and extremely fast to acquire wind holds, repeatable every time. Not 100% certain what this slide is presenting, but I believe it's a slightly different way to measure 1 mil. And with the H59, you can also count your center crosshair on that top hash. Here are different ways to measure 0.8 mils, 0.7, 0.6, and finally a 0.5 mil comparison to the H59. Now, using these slightly more complex markings, we can quickly use them to measure and acquire a hold for a known target size of 12 inches. The first speed mark drill that we'll go to is where the arrow is pointing, and then the next one starts with the double hash marks. You can see the arrows on the left-hand side. Also make a note that 12 inches is roughly the length from the top of the shoulders to the top of a man's head. Here are a few distances for a known 12-inch target. Here are a few distances for a known 9-inch target. Here are the distances for a known 16-inch target. Now we're going to do something a little different. Both of these reticles can be optimized by finding what your speed shooting gun value is. It can be done simply by finding the following two parameters. One, the optimum target range from 0.5 to 0.8 mils, and two, your elevation hold. So your rifle will retain the same number for the same size targets. Different size targets will give you different ranges. So let's run through that. Given the provided muzzle velocity and BC of a 308, you can see on the top left, you will find the provided distance information for those 0.5 to 0.8 mil range based off of a 12-inch and 12-inch only target. So from this, we, for example, at the 0.8, we carry that to a 8 plus 2.5, and we get that on all these sizes, we're roughly just over a number 10 or a 10 gun. So let's carry on that just over a 10 number to the next slide. So here we see that the known 12-inch target is milled at point H, which we know the elevation hold to be 2.5 for that combination, one from the previous chart, but also we can use our 10 gun number. So from a 0.8 we get 8, and we subtract that from the roughly 10 gun number and find that we're at a 2.5-ish hold. Since we established that we're roughly a 10 plus number, we subtract the 7 from the 0.7 mil measurement of the known 12-inch target to get roughly a 3 mil hold. For a 0.5 mil target, we subtract it of a known 12-inch target. We subtract it from our 10 gun number and get a 5 mil hold. Now you see our holds for the given 12-inch known target size at various distances, and you will see bullet impact in red. So if you're shooting a 10 gun, then hold the mil line at which you measured at on center of target for a rough impact. You can see the bullet impact in red, the target in blue. The TReMoR 2 reticle has standard wind holds at 1 mil intervals that we mentioned previously. But finally, we get into the TReMoR 2 wind hold dots. This is genius. I believe it's Todd Hartnett that says that he discovered this almost by accident, realizing that these wind holds could be held for any caliber, and roughly based on the BC, which we'll get into. And we'll show you how to calculate your specific wind hold values. So the TReMoR 2 wind holds remove the need to put wind information into a ballistic solver, along with eliminating the need to dial for wind. There are multiple ways to discover your wind value for this reticle. Currently, the Horus Vision website is being upgraded, so in the meantime, you can use your Kestrel that if it has Horus Vision software or any ballistic solver. Let's look at the ballistic solver method. So using your ballistic solver, probably an app you have on your phone, work your numbers to find, so distance and wind, to find what a 2.5 mil hold, either left or right, is at a 4 mil hold target distance. So the reason that the fifth wind dot happens to be fairly close to the 2.5 mils, so that's why we're using these numbers. So in the example, this is a 308 175 grain bullet, gets a 20 mile per hour wind at precisely 4 mil elevation hold and 2.5 mil wind correction. Now we divide that 20 miles per hour by the 5 wind dots and discover that our wind dot value is 4 miles per hour. So now each wind dot represents an additional 4 miles per hour for this particular rifle's wind dot number of 4. So it is worth noting that this can change ever so slightly based on atmospherics. So after we determine using our gun number on a known 12-inch target or using a ballistic solver to find our elevation hold, we can use these wind dots for correction. Even say the wind is gusting from 12 to 16 miles an hour, you can bracket it. So 12 divided by 4 means that that's a 3, and 16 divided by 4 equals 4. So remembering that our wind dot value is 4, then we place the target so that the third and the fourth wind dot are bracketing our target. We can use a ballistic solver to see this, but generally speaking, as long as we're using higher grain bullets, we simply use the BC of the bullet for our wind dot value. For example, a 223 or a 556, we'll say a 75 grain bullet is in 3 mile per hour increments. So the wind dot value for a 223 or 556 is 3 mile per hour increments. 308, we already established that it's in 4 mile per hour increments. Even in 338, 5 mile per hour increments. So roughly speaking, as we saw, a 0.5 BC gives you 5 mile per hour wind holds, 0.4 and 0.3. So here's one last practice to see what we're capable of with the TReMoR 2 reticle on the fly. So you're shooting and you know that your target is 12 inches, but it's at an unknown distance. To find the distance, we must find how many mils the target covers. So we mill it using the TReMoR 2, and we see that it's 0.7 mils. You can do that, of course, a number of ways, different stadia lines, but we see that it's 0.7. Knowing you are a 10 gun, you know that 10 minus 7, we get the 7 from the 0.7 mil size of the target. We see that we're at a 3 mil hold. Now to compensate for, let's say, a 12 mile per hour wind, knowing that we have a 4 mile per hour wind dot value, we count over 12 divided by 4, so 3 wind dots off of our 3 mil hold. And now, using a ballistic solver, we see how close our point of aim is to our actual point of impact on a 12-inch target at a previously unknown 435 meter range. Again, I'd like to say this presentation is not mine. Horus kindly sent it to me in an email, and I just wanted to share this introduction to the TReMoR 2 reticle for those who have it and want to take use of its full capabilities, or all who are looking to take long-range precision shooting to that next level. So I'll finish with leaving 2 detailed images of specific measurement breakdowns of the reticle. Thanks for watching.